At LP Toledo, the air pollution control devices that we employ are thermal oxidizers. Each of our high-velocity hot air ovens, which are natural gas fired, have attached to those a thermal oxidizer or incinerator that is part of the oven. As the oven is used to accelerate the evaporation of the VOCs from the coating, those then are collected and ducted to the incinerator portion of the thermal oxidizer, where there's a tube bundle and exposed to a flame that's operated at 1250 degrees Fahrenheit. The destruction of the VOCs take place, and then the residual air from the operation is emitted into the atmosphere. Since our plant was originally equipped with thermal oxidizers, it's difficult to say what the cost of retrofitting an oven would be, or adding on an oven or a thermal oxidizer would be to an operation. I would guess that in our case, each of our ovens would require a $500,000 to $750,000 retrofit if we were to do that in 2001 dollars. So they're not expensive or not inexpensive, and that would be a consideration for control, is the capital cost of adding on a thermal oxidizer versus an RCO or an RTO or a biofilter, which would cost significantly more. If that's a necessity for a company looking to add on control, one would have to weigh the total capacity of the plant and the total output from an emission standpoint to determine what the best means of control would be. In our case, though, I would guess that we would be in that range of additional monies required to add that control. Again, the cost of associating a thermal oxidizer would vary depending upon its size. In our case, we spend roughly $180,000 to $200,000 annually to operate a thermal oxidizer. The annual operating cost for a thermal oxidizer in our case is, again, would depend upon the size of another manufacturer if they were to add this on. But in our case, the way that the thermal oxidizers operate, obviously they're natural gas fired, so we have on one hand the cost of natural gas. We've added additional fume tunnel controls and fume lids for our operation that also take the fugitive emissions and that air, and then through the use of fans duct that into the incinerator itself. So you have the connected horsepower required to operate 5 and 10 horsepower motors to get the movement of the air from those areas where we're both capturing not only the VOC emissions inside the oven, but post emissions after the oven, after the drying begins to start. So in our case, where we would spend $180,000 to $200,000 annually to operate our incinerators and our thermal oxidizers, roughly 80% of that cost is in natural gas. The remaining portion is in the operation of the connected horsepower for the various motors that are used to duct the air into the incinerator, and then the resulting maintenance cost for upkeep on that equipment. The advantages of controlling HAPs and VOCs with thermal oxidizers is that it gives us the operating flexibility to use those devices to meet certain physical properties with our products. There may be times where a water-based coating isn't designed or developed to the point where certain physical properties are necessary or met. The then solvent-based coatings can be used in place of a water-based coating, and by having the thermal oxidizer gives us the operating flexibility to use those and to meet the desired physical properties for certain products. So it widens our opportunity to produce this broad scale of products that may not be capable if we didn't have thermal oxidizers.